All right, so we already did our simple factoring, so let's kind of jump into some other stuff. So for this equation, I only have two terms. Now there's only two ways to factor a binomial. One is in the difference of two squares. Or you can factor with the greatest common factor. So if I take a look at my two terms that I have x squared and I have 3x. I need to first check and see, are they perfect squares and is there a different sign between the two of them? If I look at x squared, that's a perfect square, that's x times x. If I look at the center for my term, I've got a negative term. So that works so far. So far, we have the difference of two squares. However, when I look at my last term, I have 3x. That is not a perfect square. So I know I am not factoring using difference of perfect squares. I know I'm going to factor using a greatest common factor instead. So let's just rewrite the equation. I need to figure out what term or what part both terms have. Now, there's no number in front of my x squared. There's no leading coefficient. But you know that that's an imaginary 1. Well, there's no number that goes into 1 and 3, so we can't pull out a number. So let's look at the variables instead. We've got x squared, and we've got x. Well, both terms have x, so I know I can pull out x. I just need to figure out how many. Negative 3x only has one x, so I can only pull out 1. What I'm really doing is when I pull out a greatest common factor, I'm dividing each term by what I pull out. So I can take my first term, which is x squared, and divide it by x to figure out what's now left inside the parentheses. When I do that, I know I have x left in the parentheses. And if I do negative 3x divided by x, those x's would cancel, and I would just be left with that negative 3. Now I have two sets of material to set equal to 0 in order to solve. Because if you ever look at directions, it sometimes will just say solve. Sometimes it'll say factor. If it says factor, this would be your answer. However, if it ever says solve, what it actually wants is it wants you to put x equals something. In order to get that here, we're going to take both items, both sets of material, so x, and then x minus 30. And we are setting both sets of material equal to 0. That's going to allow us to find the roots. Okay, we're not looking for factors, we're looking for roots. Well, there's nothing left for me to do with x equals 0. That is a factor. There's no adding, there's no multiplying, there's no subtracting, dividing. Nothing to do here. Okay, so I'm done with that one. But I need to do something with x minus 3 equals 0. In order to get x alone, I would be adding 3 to both sides. And I would end up with x equals x equals positive 3. I'm done solving for x. So now I've got my two roots, exactly what it wanted. I've solved for this equation.